vlog. This vlog will have two parts. Just to add the flavor, I've added one for IoT security and one related to blockchain security. As part of IoT security, I'll be covering crawling and generating custom word lists for dictionary based attacks. We'll be talking what is crawling and about the tools that are used. How is it useful? Then we'll see the demo about cool CeWL. Then we'll see the second demo on crunch. Post that, I'll start with the second part, that is blockchain security. In blockchain security, we'll be talking one of its part, that is sharing a secret. In this, I'll describe what are the basics of blockchain and Bitcoin, the possible attacks and needs of sharing the secret, the techniques used in sharing the secret. Then I'll show the demo and implementation of the technique that I'll be showing. In the demo, I'll show the Python code, how we can incorporate it using the Python and how to achieve it. It will be ended with some of its application. Let's start with part one, that is crawling and generating custom word lists for dictionary based attacks. So let's quickly discuss what is website crawling. See, website crawling is an automated fetching of web pages by a software process. It's a fully automated process. Here, what our crawler does is it analyzes the content of a page, whatever links we are providing to them, it goes through those links, then it tries to fetch and index. Then it uses that capability, then it generates the custom word list, which can be used for cracking purposes. For example, let's say I need to break some IoT device, or I need to break in or whatever malicious user wants to do. He will have a good number of words in its dictionary which can be used to crack the particular password. But let's say if it's for a particular organization, let's say if it's for an IIT university maybe, so then there is a tendency for a person that he will try to use the passwords and all related to that particular organization or some other things also. But yeah, there are some chances. So that's why we'll be crawling the particular websites or the targets per se, and we'll be using to generate that word list, and then we'll try for brute force attack. This will be the whole process. Let's talk about our part one, which is cool tool. CeWL, as name says, it's a custom word list generator tool. It's actually a Ruby program that crawls through a URL which is defined or given as a target. Then it produces the keywords. Then we can use those particular keywords with some hash cracking tools like John the Ripper or any other tool, and can achieve our purpose of cracking. As you can see in the screenshot, it is a usage of the cool tool. These are the help options which can be used. Demo 1. So firstly, we'll see the demo of cool. So there are many options that time. Let's say in google.com, a word omega is used, let's say 5 times. So it will write omega comma 5. This is how it will tell me how many times particular words are being used. Then cool website name -m and n. So it will help me to create the words with length of at least n characters, I can say. Then cool website name -e-n is used to retrieve the email IDs. Just mind -n is used to suppress the words it went through, and it will only give us the required details. That is -e, we want only the email IDs. Then we can use cool website -debug with, then we can switch to a debug mode, and we can use it. Let's quickly move towards to the Kali Linux and see the demo of it. Okay, so here is a terminal. Since it will take some amount of time to do the execution, so I've already executed these commands in advance so that I can show it. So I've written cool www.google.com. So it is showing me all the words which are used: search, HTTPS, policies, Google, com, images, this way. So this is a basic one. terms, privacy, Google solutions about. Then -C option. So I have used the same -C on the M5. So what it will do is it will help me to create the word, to find the words with at least length 5. So see, this Google is 1, 2, 3, 4, 5, 6, length of 6. So here, and I've used -C also, so it will give me the count also. Okay, so it has given me all the words with minimum length 5. Then I am using NIIT University here, and I've used the option -E, which will help me find the email address. So on NIIT University site, it has scrolled and it is able to find all these email IDs. Okay, so this is about the cool demo. Let's move to our second tool, which is Crunch. So in order to crack a password or a hash, we need to have a good word list that could break the password, right? So Crunch is also a word list generating tool. This generates the word list based on some specific target. So here we can have some usage of words, or we can, let's say we know, okay, these were the minimum length of the password that could have been used, or we have some regular expressions, let's say words start with this particular length, or we have some specific patterns or symbols, all the things we have. We might know, okay, this user might have used his password starting with XYZ, or let's say we know his password length is six lengths or 6 digits. So if we have these kind of options, we can use those patterns to generate. Now let's see demo on Crunch. So here are a few of the options which I'll be showing for Crunch. And as usual, we can use Crunch-H to get the help and see all the listed options which can be used here. So I'll be demoing it using these options and see how it works. The usage is very simple: Crunch, and then we have to give our targets or whatever we are interested in. So let me go back to Kali Linux and see its usage. So I have executed some of the commands which I'll be showing. The first one is, if we use just Crunch 3, and 5, is just an example. So it will generate a random word list for me that have the words with minimum length 3 and maximum length 5. Now to add more flavor to it, I have given it Crunch 3, 5, A, B, C, D, E, F. So it will generate the words only using these characters. So let's say sometimes I know, okay, password is combination of these words only. So I can generate list of all permutations and combinations. And -O option is used to bring the output into a file known as wordlist.txt. So I have given this, and if we see the output like this, A, B, so it will generate the words with minimum length 3, maximum length 5, with using only these characters, which I have given A to F for in this example. Okay, so as I already mentioned, that there is already a set of rules which are present with Crunch that can be used to generate some custom word list. So that is called charset. So we have this file present under user share Crunch, which is charset.lst. So it has some options or rules present with me. It says charset configuration file for Wingarten V1, hex lower, hex upper. So it will generate the word list using these combinations. So maybe if I don't want to give my input in that form, I can ask it to use this file and call a particular rule out of it. So lots of rules are predefined. We can also define our rules. So let's say I want to use one of the rules. See, lots of rules are there: alpha, lowercase, mixed case. Let's try with the option of hex upper. So I given Crunch minimum length 4, maximum length 5, -F. Use this file for rules. Which rule should be used? Hex upper. Output in wordlist.txt. So it will generate. So all the hex uppers, it has generated the word list for me. Lots of inputs are present in a file. Currently, due to screen limitations, I'm showing only few. But if you open that file, all the outputs will be present, maximum output it can give. Then another option is crunch. I can use -t option. So this 8 to 8 is used, that minimum length and maximum length is 8. For example, we have taken -t is like if you want to check for a particular pattern or a regular expression. Let's say my password starts with Anurag and last two can be anything. So I will give it, okay, it's Anurag percentage. So it will generate a custom word list based on it. So see, Anurag 00, 01, 02, 03, 04, 05, and so on. Now let's say I know that, okay, this list is present and I have some duplicate information as well. So let's take an example. I am giving it 9 digits and I'm adding one more percentage here. And I say I have two duplicates with me. Okay, two words have will be repeating in this particular expression. Let's put enter. It will generate some 990 words. I'll use more word list text. So it will create two word with two duplicates. See, 00, 00. So it will consider two duplicate values here. Okay. Now let's see some other option. Okay. So let's say we know the ending part and we don't know the starting part. Like in earlier option, we didn't know the ending part. So here we know the ending part, but we don't know the starting part. So we have given at the rate here, and the length is 9. I'm giving -o output will be in word list. So it will produce these starting words for me. Okay. So yeah. So what have we seen in the demo is summarized here. I can create a general word list. I can provide a rules from the char set file. If I know the starting of the file or but not the ending, or not file, the words. If I know the starting but not the ending, or if I have some duplicate information, I can use this. Now let's come to the second part of this vlog, which is blockchain security. So before I get started, I'll try to set up a platform and tell you about what actually is blockchain. And then we'll do a little bit transition towards the Bitcoin and we'll talk about it a bit. So blockchain is basically a concept which is used by some cryptocurrencies, supply chains, etc. So blockchain is a read only or one write ledger kind of thing. So even if we are using it for cryptocurrencies or supply chains, it's like a data will be written on it one time and then it can be read only. We cannot modify the existing data. This is the very important point. So in case of cryptocurrencies, it is a distributed ledger which is decentralized. So as mentioned in the slide, the Bitcoin blockchain is like an immutable database where the data can only be added. The chain has a lot of replicated databases, which is peer-to-peer network that is visible to everyone or anyone who wants to see. The peers are responsible for maintaining the integrity of blockchain and prevent all the fraudulent transactions. What is a transaction? I'll just mention about it. It's a process of transferring a coin from one wallet to another wallet and how the particular transaction happens. See, in normal fiat currency, how the transaction happens. I have a 100 rupee note, I'll give it to someone and it's a transaction. Or if it's an online transaction, I'll do an NEFT or UPI or whatever. But here, internally, if you see, I need to have a public key of the receiver. I will digitally sign my transaction. I'll send it to that receiver. Then that transaction will be added to a blockchain or the ledger, which is a decentralized one. And the miner who is mining the currency, he will add the particular transaction into that blockchain in a particular block. So once everyone agrees that, okay, this block is valid, then my transaction will be considered as valid. So if we see the chain which I'm showing below, data next, So head of a transaction is one block, and this fully is a blockchain. So let's say there are some 10 transactions in one block and some 10 transactions in B block. So how is A related to B? So there are the combination of hashes, or I would say whatever values are present in the chain, the block number one, it will be concatenated, it will be hashed, and that hash reference will be given to another block. And similarly, the hash of B reference will be given to C. So if at all anyone or any intruder tries to change the hash of B or try to change the transaction, the all the other blocks after B will be invalidated because they have the reference of it. And we know hash is not colliding, right? Let's talk about some possible attacks on blockchain. So here are some of the attacks which are mentioned that can happen. The first one is double spending attack. An attacker can try to change his own transaction, right? 51% attack, when an attacker can try to generate the alternate chain faster than the honest chain, and he will be like, okay, all the people who are working to generate the chain or add the transaction in a particular block, he will have more power, and he will try to add the fraudulent transactions and create a big chain. And this is a rule in blockchain that only the largest chain will be accepted. I can try to do this particular attack. There are some other things that can happen like frauds, malware injection, hacking, etc. in blockchain. So here I will be talking about one of its security thing, which is sharing a secret. See, if I would be using a fiat currency, I have a 100 rupee note in my pocket and it's safe with me. But now when I am using the cryptocurrency, it's all the virtual currency, right? I have no security, and total security is dependent on cryptography. There is nothing physical in my hands. So now when we are using this particular thing or the particular property of the blockchain in the cryptocurrency, so it uses many cryptographic techniques for key management. If I need to transfer anything to anyone, I have the public key of that person, but I myself will have a private key with me, correct? So that private key and public key pair will be used to reveal the money or whatever I have. So I am dependent only on cryptography for the key management. So now some problems comes. That's why we are discussing this secret sharing technique. If one person is having a particular key, and if he reveals the secret key, then whole system is compromised. So the solution proposed was is to have a key with more than one people. Let's talk about an organization. If a manager is only having a key, and if he's a malicious one, he can compromise whole organization, right? So the solution is divide the key in, let's say, all the members, and then combination will result in complete message. But the problem is, if we are dividing the key, or we are sharing the dividing the key and sharing among all, then at least each person will have some information on the secret key, right? Let's take a very basic example. Let's say my key is ANURAG, and I'm dividing it among two people. One person will get ANU, other will get RAG. So the first person who got ANU, he's aware, okay, my key starts with ANU. So he has some basic idea. So the partial idea is very dangerous, as he can do brute force the remaining part, and then he can compromise the system. Now, to solve this problem, what comes up is, let's divide the key in such a way so that no one has the idea about the uh, partial information of the key. But here another problem comes up. The problem is, if I am having 100 members in organization and I'm dividing among 100 people, then every time I need to reveal a secret, I need all those 100 people, right? So then the final acceptable solution is, as shown in the figure also right hand side. If I have 8 members in a place, I can share a key in such a way so that no partial information is disclosed, and not all people are having access to the particular revealing thing. Let's say if 8 people are there, I will, at any given time, I will need only 5 people, or a consensus form from those particular 5 people, to uh, reveal the secret. And this technique, and to achieve this, we are using a technique called threshold scheme. This is called KN threshold scheme. KN as in I have K pieces or K member as earlier shown in the previous slide. Out of K is 5 here and N is 8 here. So out of N, I need only K combination of keys or K keys, but at a particular time to reveal a secret. Hence, it is called KN threshold scheme. This is based on plotting a secret point on a 2D space. If you see the space here, I have a random point and I am plotting the values here. So once the values are plotted based on number of secrets or the pieces needed, the line will be converted into curve. We'll see how, and we will be able to reach our required solution. So let's say I am in need of only two pieces. So I will generate a line here as shown on this. Over I will plot a point on y-axis, will generate a line over it, and then I can find out any random point on this which can be used to complete this particular line, and this line will be used to reveal the particular line equation, and hence line equation will be able to find out the value of our secret. Similarly, if I want k is equal to 2, I need to have 2 points. So I will be plotting 2 points on a curve. Then I will be joining 2 points using this curve, and this curve will be a secret one. Now, after the curve is generated, I'll find out any one or two secret share, how many I need. These greens are shown as a secret shares. I will take out any random point and I will share it with among the persons. So at any given point, I will need particularly 2 points to generate this particular curve. So this is how, if as soon as the k increases, the curves in that particular curve increases, and this is how I can generate my secret shares. So this is shown as a part of in a mathematics with the equation a naught plus a1x plus a k x to the power k minus 1, where a naught is a secret message. So to get the value of a naught, we need to have all the values of x and qx so that a naught can be found. So this is a very clever technique which is used, a very simple one. We all know that if we don't have value of all the variables, we cannot solve the particular equation. So let's say I have 20 people, but I have k value as 10. So I need any 10 values in that equation, and I will be able to generate a naught. And practically, modular mathematics is used here so as to enhance the security of it. Now let's talk about implementation and security. Thus, the implementation I have done using the Python code, which I'll be showing after this. There are two steps which are implemented in the Python code. One is to generate the pieces and other is to retrieve the secret. Okay. Then if we talk about security, we used only modular mathematics to have more security. Modular mathematics, let's say if we have used mod 5. So even if we have 500 values, it will be modularized under the 5. It will have the values rotated among 1 to 5. So that a malicious attacker will not be able to use even brute force to get the values or attack it. It is so secure that even if you provide k minus 1 pieces, where the number of pieces required are k, the equation will not be solvable, right, because it's a basic mathematics, and hence the secret we will not be able to get. Now about demo. In this demo, what I'll be doing is I'll be generating some pieces. User will give me the input values of n, k, p will be a prime number. Then our code will compute these particular values using modular mathematics, and it will show me all the pieces which are generated. Then we'll see two things. How, if we are providing k minus 1 pieces, it will say I cannot reveal the secret because equation will fail. And if we provide exact k secret, then only it will be able to retrieve the secret. Let's see the Python code for its implementation. So here are the functions which are generated to generate the random coefficients, generate the pieces. Then this code will deal with revealing the secret. It will iterate through the pieces which will user will be providing. Then from user input, it needs to find out the pieces which user has provided. Then it will solve the equation to get the secret. Modular mathematics has to be used here. And this is our main function. It will ask user to provide the number of pieces to be generated, the minimum number of pieces that are required to reveal a secret. This has to be user controlled. Let's quickly run this program and see how it works. Enter number of pieces to be generated. Let's say in my organization, I have 10 people. Okay. Let's generate 10 people. Enter the minimum number of pieces required to reveal the secret. Let's say I want only uh, my manager and myself to reveal the secret. Okay. Or any two people can reveal the secret. Enter a secret. So let's say my secret is 1000 hex value of something. Enter a prime number that must be greater than 1000 and n is equal to 10. So let's give a prime number 1. Okay. So it says given secret is this randomly generated coefficient. It is dependent on coefficients. Okay. For the solving the mathematics. So it has generated 10 pieces for me. These are the 10 pieces. So I need to provide any two pieces to generate the secret. Let's say I provide, so piece should be provided in piece value and piece number. Let's say my piece number 862, which is piece number 1. Let's say I provide that and I press enter. Pieces number provided is 1. Sorry, secret cannot be revealed with a given number of pieces. Right. Because what I asked was I should have two pieces minimum required to generate the piece secret. Let's run this again with the proper values. So 10 to secret was 1000, 1111. Okay. Now it has generated n pieces for me. 373, 1, comma. This time I will give two pieces. Any two pieces I can give. Let's give the starting two. Eight 57:2. Okay, it is taken the wrong value. Sorry. Okay. 1047:1, comma 1094:2. See, two pieces values I'm giving you. And yeah, see, it is in pieces provided. Then it has solved the equation and was able to reveal the secret, which was 1000, and it was given by us. So yeah, this is about the implementation of it, of the demo. So I'll end this vlog with some properties and its usage. So it says the size of piece does not exceed the original data, hence it is easy to share, of course. We can keep the k value as fixed and we di can be added or removed. Let's say people are coming to a company and they're going to a company. So of course we cannot reuse their secret. We need to discard that value. So it's really easy with this particular piece of code. We can discard some values, we can generate new values anytime, and we can generate infinite number of values. We can easily change the value of d without changing the original value. We just need to keep a naught fixed. A naught is our secret, which will be keeping fixed, and it's in reference to the previous point that only if secret is fixed and other values in the equation are fixed, new values can be added up easily. We can use a tuple of values to generate a secret. It will help us to create a dependency on number of people. Let's say I want that every time a secret is revealed, and let's say only minimum two people are required, but one out of that person should always be manager. It should always be manager plus some other person out of that 10. So that kind of conditions also we can apply. So yeah, this is about secret sharing. This is a very secure practice which is used in our cryptocurrencies also to secure the values of our private keys, or it can be used at other places also. Uh, this is very important for the security purposes, as it is very helpful and easy to implement. We all know how the data can be compromised.